discussed the regenerative braking. Today we will discuss the other two braking techniques. Sorry, there is also a typo error here. It's braking, not braking. Okay, so today we will discuss the counter current braking, يا شباب, which is sometimes called or referred to as terminal voltage reversal. Simply like what we made in induction motor, in order to make counter current brake, we just change the polarity of the supply, which is in AC made by changing the sequence from ABC to ACB. However, here in DC motors, we can just reverse the terminals of the supply. So if we are operating the machine here in motoring mode, this is the motoring mode here. Okay, so if we reverse the supply, شباب, here like that, it will be operated in reverse motor. Type. We now need to recognize the characteristic of the machine, what will happen, and also how we can implement the counter current braking. Firstly, in mode A or motoring, this is the characteristic we know. So if you operate the motor at a certain load, for instance, at this operating condition, and you reverse it, the motor voltage and the load torque is reversible, so you expect to operate at a point here at the same value of load torque. So if this is TL, so at minus TL, you will operate the motor at the new operating point. How we can do that? Using the 4-quadrant DC chopper or Class E DC chopper, just as we discussed in the previous class. Yani instead of operating using Q1 and Q2, just operate using Q3 and Q4. In this case, the current will be reversed to be IB like that. Okay, so this is, شباب, how we can make that. Let's discuss in detail, شباب, the dynamics during the transformation from positive to negative speed. As we discussed previously, شباب, يعني the motor cannot be changing its speed at 0 time. So in order to move from point number 1 to point number 4, which is the reverse motor operation, there are some steps in between the motor has to follow. So simply, for the first instance, if you change the supply from V1 to V2, which means you reverse the supply terminals, in this case, the operating point 1 will be changed to operating point 2 at 0 speed change. So now, the new curve, this is electrical characteristic curve of the motor. So the new curve, or at the new curve, the motor speed will be here now, because there is no change in speed between point 1 and 2, which means only the electrical torque has been changed. Electricity change is fast compared to mechanical change. So instantaneously, if you reverse the terminals of the DC supply, the motor will move to the operation at point 2. But at this point, شباب, what is the mode of operation here? At point 2.
Regenerative.
Regenerative, exactly. So here, the machine is working at regenerative braking. Right. Now, because our load is reversible, which means the reversal, the torque load is active load torque, so the value of the load torque will be minus TL. So simply, the electrical torque has to follow the mechanical torque. So the speed will be decreased gradually until reaching to point number 4. So if we reach to point number 4, the machine will work at reverse motor. So if I would like to make stopping to the motor, يا شباب, which point we can consider it as motor has 0 speed?
3.
Point number 3. So if we add mechanical clutch here, it will stop the motor at that point. So just adding a mechanical switch to detect the motor speed. If we reach to point number 3, it will disconnect the motor if we need to stop our motor at or using counter current braking. Okay, so again here the typo, sorry. I will modify it شباب in the version on Blackboard إن شاء الله. طيب. So now we could recognize the characteristic شباب, and for sure in order to change the motor from point number 1 to point number 4, there will be a stage in the transformation. This stage will will be the regenerative stage. So the machine will return some energy to supply in order to reverse the motor speed. Actually, we discussed this on MATLAB Simulink in the last class, and we could see that there is a part of the energy or power will be returned to supply due to just reversing the motor speed. Right. So what are the relations that we can use شباب in these cases? طبعا for point number 1, the operation is only motor, so we can use the same motor relation, which is E equals K phi multiplied by omega, V or EMF equals V minus IARA, and so on. All of the relations used as a motor. At point number 2, the torque electrical is in negative, okay, and the speed will be in positive. So at point number 2, the relations we can use that, firstly, V2, which is the same value of the supply voltage, but in negative sign. So equals minus V1, which is equals to E plus IARA. So it's E, which is K phi, plus IARA, because the torque now became negative. So this will be the relation now, and the value of current can be minus V minus E over RA. So this is now شباب representing the point number 2. Right. If we moved to point number 3, طبعا at point number 3, what is the value of speed? It's 0, is it right? So for now, the EMF here will be 0 because there is no speed for the motor. So K phi multiplied by omega will be 0. So at that point, we can say V equals IR. So at point number 3, we can say I3 equals minus V1 over RA, because the current for sure will be reversed. And we can say also V equals R multiplied by T over K phi, where I equals T, which is the electrical torque at point number 3, over the value of K phi. For point number 4, يا شباب, it will be completely like point number 1. However, everything is reversed. Speed is reversed, torque is reversed, okay, and current is reversed also compared to point number 1. So for point number 4, it will act as reverse motor. طيب, now يا شباب, here, if you have a look here to point number 2, what is the value of current? We said that at point number 2, I equals minus V minus E over R. طب let's say طبعا E at point number 1 and at point number 2 is the same, because flux is the same and speed is also the same. So if we have in the operating mode here in motor, let's say V was 220 volt and E, for instance, due to the voltage drop, will be, for instance, 210 volt. So if you reverse it now to the sequence here, or sorry, reverse the electrical torque and operate at point 2, so it will be now, in terms of the same values, it will be minus 220 minus 210 over the value of resistance. So what happened, شباب, to the current here?
Increase.
Compared to the motoring mode, you will find that the braking current here is very high. So, in order to make the operation safe in braking or reverse or whatever, we can add resistance. This resistance, we can call it as braking resistance, RB. What is the aim of this resistance, شباب? The aim is to limit the braking current value. in most of problems, you will find that we can limit the current to twice of the rated current. يعني all of time يا شباب, when we limit the motor current in starting or speed control or dynamic braking or any kind of braking يا شباب, okay, we should limit the current to twice of the rated value. This is a safe operation margin for DC motors. So you sometimes need to calculate the value of resistance which required to operate the motor safely in the braking time. So in this case, we can consider that the value of braking current is twice of the armature current at full load. Right. So if we add the resistance, what will be the relations now? So we can say now minus V, because the voltage is reversed, equals Ka phi, which is EMF, plus Ra plus Rb, multiplied by current, which is torque, over the value of Ka phi. So here you will find that the term Rb is inserted, because we insert a resistance. So this is going to limit the braking current. As you can see here, Rb is inserted in the denominator of current in order to break or limit the braking current value. Finally, at point number 4, so when we reverse the supply and move or add resistance, so here in this curve, R braking equals 0. If we add the resistance, so assume that we have a value for R braking, so we'll move to another characteristic here. So the current will be reduced to point number 3. Okay, شباب? Then at point number 4 here, this is now the steady state operation of reverse motoring. We can say now the relations minus V, because voltage reversed, equals E, which is Ka phi, plus R total over Ka phi multiplied by minus T. Okay, شباب? So this means that all of relation is multiplied by negative sign. So it will be the same like the motor operation now. Is it clear يا شباب? Relations for all of
I have a question, if you allow me to.
تفضل. تفضل.
We didn't face this problem in the induction motor, am I right? In the
induction motor, we didn't solve some problems, you mean, صح?
No, we didn't face this problem to adding this resistance because of the current will be high.
It could be also increased in the induction motor, by the way, but we did not go to the analysis in details. تمام? In that case, instantaneously when you reverse the supply, you will have the same. You will have high current during the instant of reversing. Later inshallah شباب, maybe in the last topic in our course, which is the variable speed drive, I'm going to make a simulation for variable speed drive in the reverse motoring, and we can discuss together the value of current when we reverse the motor direction. It will be very high instantaneously, actually. Okay, after reaching to the steady state by the same the way. Okay, but we didn't cover the analysis for that. تفضل.
Sorry, Doctor, I have other question. The current, what I think that the current has minus sign in the regenerative quadrant, which is second and the fourth quadrant. Why we say that in the third quadrant would be minus?
Let's go to the second quadrant. Here in the second quadrant, current will be also here will be negative. صح? Here yes. This is the volt and this is current here. Okay, so either in this region, which is number 2 or number 3, current will be negative. So as you can see here, the current will be finally a negative sign. The same is also here in I2. Okay.
But the current, the sign of the current represents the direction. Am I right?
Yes.
So in the third quadrant will be as a motoring mode.
It's not motoring. It's reverse motoring.
Oh, so, sorry.
So the signs of speed and torque, or in voltage and current, all are reversed. Okay, compared to the operation in mode number 1.
Can we say that in the fourth quadrant the current sign will be positive?
Yes, sure. يعني here in the as in the quadrants here, the current here is in positive. Okay, يعني all يعني region 1 and 4 current is positive. Region 2 and 3 current is negative. تمام, according to the 4 quadrants here, just mathematical representation. Okay.
Because I thought that the sign will represent if it's motoring or regenerative braking mode. So I know this is my mistake. Okay, thank you, Dr.
يعني according to the signs of the 4 quadrant, يعني motor operation or regenerative of reverse motoring, both will be in positive sign of current. Okay, which is quadrant number 1 and 4. And regenerative braking or reverse motor, the current will be negative. Okay.
Okay, thank you.
So شباب, as a summary for the terminal voltage reversal or counter current braking, let's summarize the signs of all of modes again. So for motoring at operating point number 1, the motor torque is positive, terminal voltage is positive, current is positive, speed in positive sign and or direction. طبعا field, we are not going to change anything regarding field يا شباب for all of types. We will fix the field. Otherwise, if you change the field as well, so يعني this means K phi will be negative يعني by the same way. So in this case, the motor will be reversed. Okay, so we will keep all in all of our work the field, direction, and current value as constant value. Based on that, شباب, you will find in motoring E is positive. However, if we go to mode number 2, which is regenerative, so you will find that the motor torque is reversed in negative sign. Terminal voltage also is reversed. The armature current is reversed. The motor speed will be the same value of speed because we said يعني at the same time or instant the speed will not be changed. Okay, because the change in mechanical systems takes time. So speed at point 1 and 2 will be the same and the same value and direction. And finally E will be the same. And all of time, شباب, since speed and field are the same, the EMF will be the same. At the holding point, which is the point if we disconnect the motor, so in this case, شباب, the motor torque is in negative sign. The terminal voltage is already in negative sign. The average current or the armature current, sorry, is already in negative sign, and the speed will be 0. This is holding point. So we can stop the motor at that point. And finally, at reverse motor operation at point number 4, so the motor torque is negative, terminal voltage is negative, armature current is negative, speed is negative. So if you compare all of these quantities now as electrical and mechanical, you will find everything is reversed. For that, we call it reverse motor. Okay, and only the field will be in the same direction. And because the speed is reversed and the field is in the same direction, the EMF will be also reversed. So this is a summary for the counter current braking technique. Right. Now let's solve some problems regarding the reverse motoring. A DC motor has armature resistance of 1 ohm. KFI is 3 volt second. When the motor terminals voltage is adjusted to 320 volt, the speed is 1000 RPM. So up till now, this is considered as motoring operation, normal operation. Why it's given? We said before, شباب, in order to calculate the motor constant, we need an operating load condition. So this is the operating load condition here. This is the value of volt. This is the value of speed in order to obtain KFI. So by default, the first step will be used is to calculate the value of KFI. But here, شباب, KFI is given. Sorry, here KFI is given. So we will use this data in order to get the machine current. Type. Calculate the braking resistor. So we are going to make now, a TVR. طبعا TVR, we said it's abbreviation of terminal voltage reversal. So it's counter current braking. A TVR braking is applied. So this means now you are going to reverse the motor speed and add a resistance. Sorry, reverse the motor terminals and add resistance. Calculate the braking resistor. Also braking here يعني need to be corrected. Braking resistor that would reduce the minimum braking current to twice of rated value. As we discussed يا شباب, twice. All of time it's twice. Okay, so this is يعني the limit of armature current. We cannot increase over twice of the rated value, otherwise it will affect the motor lifetime and safety. So now it's needed to calculate the value of braking resistor. In order to do that, we need first to know the motor current at the first case. So at the first case, which is motoring mode, we have the operating condition. We can say now I equals V minus E over R. So simply we have terminal voltage is 320 volt. EMF can be calculated as Ka phi multiplied by speed, okay, multiplied by pi over 30 because this is speed in RPM. So this is the value of Ka phi divided the value of Ra, which is given as 1 ohm. So simply you can get the armature current. So this is now the armature current at motoring mode, point number 1. Now we need to get the value of braking resistor. So now شباب, we are going to operate at point 1, 2 or 3. The curve, the machine will operate at which curve يا شباب?
We want it to be at 3.
Exactly, because we added already resistance. So now, because we add a brake resistor, so immediately if we reverse the supply, the machine will work or transfer from point 1 to point 3. So this is now the operating point. But what is the value of resistor in order to limit the current to twice of rated current? يعني as you can see يا شباب, يعني this is here the load torque, which is equivalent to that. So the current is almost twice the value. Okay, current here is twice the value approximately. يعني curve is not made to scale. However, يعني it's like that. يعني almost twice of the rated current. Okay, طيب. So now يا شباب, you know that the value of current is 6 amps. So twice of this value is 12 amps. So you need to calculate the resistance based on the current value of 12 amp. طيب, what is the relation at point number 3 or even point number 2 in regenerative braking generally يا شباب? The relation is minus V because the voltage reversed minus E over total resistance. So you have V, which is 320. You have K phi motor constant is already 3 voltage second per radian. Omega is the motor speed, okay, which is 1000 RPM. This is the required here يا شباب at point number 4. Okay, so يعني either point number يعني 3 or 4 the current is reversed. So for now we can say the value of RA is given 1 ohm, and the only unknown here is RB. Okay شباب, so we substituted now not at point number 3, we substituted actually at point number 4 where the speed of the motor is in 1000. Sorry, at point number 3 where the speed here is 1000 RPM. Okay, so this is now at point number 3. This is right. Okay شباب, طيب. So يعني at point number 3 for sure the current is now twice of rated current, okay, which is 12 amp. So this is now representing operating point number 3. Based on that يا شباب, we could obtain the value of adding resistance. So it's 51.8 ohm. طبعا يا شباب, يعني if we operate the motor on this curve for all of time, this will be يعني totally lost, because the losses here will be very high. Can you imagine? The current is 12 amp, okay, and sorry, the current here will not be 12 amp. If we turn back to the 6 amp again at point number 4 here, the current will be 6 amp for instance, and the resistance is 51.8 plus 1. So I square R will be very high. So we cannot continue operating at that curve يا شباب. So if we decide to operate the motor at reverse speed, we should remove the braking يعني resistor after moving the motor in the other direction. So once we operate the motor at point number 4, we can remove the value of RB. In this case, شباب, exactly what will happen, the motor will move to that point, assume this is point number 5, and will return back to point number 6 here. Okay, so this is now the final point if we remove the braking resistor after reaching to point number 4, شباب. And this is the logic way to operate the motor in reverse motoring. Is it clear, شباب?
Sorry, doctor, that means when sensing that the speed is equal to 0, we'll remove the adding resistance.
لا, it's not at 0 now. يعني we moved now to point number 4. Let me remove the lines on the graph again. Again here. Now, after moving to point number 3, we moved from 1 to 3, then from 3 to 4. Now the final operating point is number 4, because this is now considered as minus TL. However, the speed is not similar to speed of the first operating point. Is it right? And speed
Yes.
at 4 is lower than, طبعا it's opposite direction, but still lower than the speed at point number 1. So we should continue up till reaching to the same speed. How we can do that? By removing the braking resistor. So if we remove the braking resistor, so in this case, the operating point will be moved at 0 change in speed, which means moving in that direction to that point, وليكن هنا يعني point number 5, and it will continue until reaching to point number 6, which is the motor speed equivalent to the one at the forward motoring, which is 1000 RPM. Is it clear?
Yes, it's clear, but in practical, how can we remove the resistance?
يعني resistor value can be controlled easily. يعني we discussed this previously using starter. And if we go back to starter, there is mechanical way or electromagnetic way, which is the motor starter like that. It can be used also by the same way. However, in power electronics, we do it in different way, and we will discuss it, inshallah, by the end of this class, by using also switching in order to control the value of resistance itself. Right. So this is, شباب, يعني the summary of the counter current brake. Another type of braking, شباب, is dynamic braking. Dynamic braking. What is dynamic braking? We discussed previously the meaning of dynamic braking in induction motor. Dynamic braking means disconnect the supply and add a resistor. This is the meaning of dynamic braking. Type. If we do that in DC motor, if we disconnected the motor supply and added a resistor instead, in this case, the energy stored in the inertia of the machine, which is the kinetic energy, will be dissipated on the resistance as electrical power or electrical energy. So we can say now the braking current equals EMF over RA plus RB, where RB is the braking resistor and RA is the armature resistance. And for sure it will be in minus sign. Why? Because the energy will be returned to the supply. This means the current will be reversed. But you know that E equals Ka phi multiplied by omega. So this is now will be the relation minus Ka phi omega over total resistance. This is now considered as the braking current. So the higher the braking current, the higher the braking resistor, the lower the braking current. صح ولا غلط شباب؟ Is it clear? If we added higher braking resistance, this will reduce the braking current. But what about the energy and the energy consumption, or we can say the time of braking? Is it going to be lower or higher with small current? Yani if we limit the current to small value, will the motor stop in fast time or in slow time or a slow way?
Be slow.
Slow, exactly. So now we have two boundaries or two constraints. One constraint for current, it has to be lower than twice of rated. And another constraint is the time of braking. We need to fast stop the machine if we have a problem. This is the aim of braking. So we should design our braking resistor based on that يا شباب, to limit the current to the maximum value, which is twice of rated current. طيب, what is the power value or the power dissipation equation? We can say the power equals power of braking equals E square over RA plus RB, which is Ka phi omega square over total resistance. So these are the relations which are describing the dynamic braking. Let's see together the characteristics and practically how we can do that. Firstly, this is the motor characteristic. Assume we are operating now at that point at current A. This is speed versus current, not torque. Okay, so this is now the operating point. If we use a certain braking resistor RB1, where RB1 is smaller than RB2, smaller than RB3, you will find that IB1 is high, and so on. If we reduce the value of, if we need to reduce the value of current, the resistor has to be increased like that. Okay. So this is now representing the motor characteristic. But why the curve is moving like that? It's not moving similar to the other curves here. Can you see here? The other curves here are not moving to the origin. It's moving or cutting the torque or current axis at a point and then continue to the no-load speed. Why in this case, شباب, there is no no-load speed? Why in the new curves we have no load speed? سؤال سهل يا شباب. النو لود سبيد الريليشن بتاعتها ايه؟
The terminal voltage.
Exactly, V terminal over K phi. صح?
Yes.
This is now no load speed. So because the voltage zero, because you already disconnected the voltage, you have no voltage now. Is it right? You shorted the motor, so you have 0 voltage. This means now the voltage will be 0, so the no load speed is 0. صح? For that, all of curves here will go or pass to to the point of origin. Okay, because the no load speed is 0. So in this way يا شباب, the motor will go to 0 speed only if the load is gravitational type, which means by gravity it can continue in reverse regenerative braking. We have to add a mechanical clutch here to avoid continuing the operation to the other A side. Type. Here we have some notes. Moving the switch from point A to point B will disconnect the motor supply and connect the braking resistor RB. So we will disconnect supply by moving switch from point A to point B, and the adding resistor will be there. The braking current relation with the speed can be represented as in figure. This is the figure what we have discussed. We have note here, the higher the resistance value, the lower the braking current, and the slower machine shutting down or shut down. And the reverse, the smaller the braking resistor, the higher the braking current and the faster stopping of motor. Type. If we have gravitational load torque, which means by means of gravity, the motor or the machine can continue working in the region number 4 here, in quadrant number 4. So this means the machine will not stop here. It will continue and the speed will be reversed to reach to point number C here. This is in case of gravitational load يا شباب. And this is also a summary for our dynamic braking techniques. I will leave this table for you, and it's now very easy. You can deduce the different signs easily here by the same way we made for regenerative and counter current braking. Now we have an example here. The DC motor of previous example is loaded by gravitational load where the motor current is 40 amps at steady state condition. So this is the motor at forward motoring mode. If the DC source is replaced by a braking resistor of 2 ohms, so this is RB, calculate the motor speed at the new steady state operating point. Because it's a gravitational load يا شباب, so new operating point will be point number C here. Okay, so the motor will not stop. It will continue at point number C. For that, we can say now at point number C, we can say now the steady state current at point number C equals the steady state current at point number A because it had the same load. So we can say I braking equals minus, because it's reversed now, minus E, which is K phi multiplied by motor speed divided by RA plus RB. So the only thing will be different here is omega. Why? Because we added resistance. So you have the value of current, you have the value of armature resistance, K phi is given, braking resistor is given, you can easily obtain the value of speed. So the motor speed will be reversed, it's a negative sign, and the value will be 231 RPM. طبعا يعني it should be calculated here يا شباب firstly in radian per second, and finally you can just multiply by 60 over 2 pi, okay, in order to get the value in RPM. Another example regarding the braking, the dynamic braking of DC motor. DC motor has the following data شباب: 81.5 ampere, 15 kilowatt, this is out of power, 220 volt, 1600 RPM, RA is given. Calculate the braking resistor required to stop the motor if the motor was working at 1630 RPM, giving that the motor current has to not exceed the maximum or the current where the load torque is 180. يعني it's not here stated that twice of rated current, it's stated that the current of 180 Newton meters. So we can say I equals 180 over K phi in order to get the maximum current we need. So simply يا شباب, we can obtain the value. How we can obtain the value of resistor? يعني firstly we need to calculate the motor flux constant. It's not given here, but we can obtain it from the given data. You have omega or N, you can convert it to omega, and you have power, so you can obtain the value of torque, and then you can so this is the value of torque. I think torque is needed or not needed. Torque is not needed. This is extra, يعني you don't need to calculate it, or maybe it was exist in the problem before. يعني you can obtain now K phi as E over omega, which is 220, this is the volt, minus 81.5, this is the current, multiplied by RA over the value of omega, which is obtained here. So this is now representing K phi. Now going to the braking mode, okay, which is in the other quadrant. So we can say now we need the value of resistance. So we can say now omega B equals IA multiplied by RT over K phi. طبعا يعني omega B multiplied by K phi, which is the EMF يا شباب, it's equal now to IA RT, because EMF is equal to I multiplied by total resistance. Now you can replace the value of current, because we don't have the maximum current value, by T over K phi. So we can say T multiplied by R total over K phi square. And it's stated that the speed will be limited to 1630. So this is now the braking speed we need, or the braking point of speed. So speed is 1630 multiplied by pi over 30 to convert to radian per second equals 180, which is the torque, multiplied by R total over K phi square. We obtain K phi from here. So the total resistance is 1.4, and we already have the value of RA, so we can easily obtain the value of braking resistor. So we obtain now the braking resistor that will limit the current to the maximum current, which is occurred at 180 Newton meters. Okay. طيب. يعني here take care that يعني 180 is almost twice of the rated torque here يا شباب صح؟ يعني this is 89 يعني يعني we can say 90 and 180 so it's يعني twice of the value. For that يعني the maximum current يعني as we said it's almost twice of the full load current value.
دكتور it's time for
طيب okay we can stop at this part here at solid state breaking يعني we can start إن شاء الله next class from this point. So please شباب all of you go to Blackboard now and open your exam.